Good day everyone. I am Maria Baktat from AUFB1 CE3 Main 2. So we are the reporters and we're going to discuss about the branch, circuit, and the feeder. So first is the information about branch and feeder. First is branch circuit. It is a part of electrical system that originates at the main service panel and feeds electricity throughout the structure. So sabi dito, si branch circuit daw is a particular type ng circuit na nagra-runs from a circuit breaker panel hanggang sa devices ng mga buildings. So ito yung nagpi-feeds ng electricity or nagsusupport ng electricity sa buong structure. So next is feeder. So feeder circuit is a conductor or group of conductors and associated protective and switching devices installed on the surface in main entries or in gangways but not extending beyond the limit set for permanent main wiring. So sabi, ito yung conductor in between ng disconnecting means or circuit breaker. Halimbawa, may tatlo tayong circuit breaker and yung mga from first circuit breaker hanggang sa last circuit breaker which is yung panel board, yung mga wirings sa mga pagitan ng bawat circuit natin na nagko-connect sa kanilang tatlong circuit breaker ay ang tinatawag nating feeder. So next is the overhead service. Service is normally tapped onto the utility lines at a mutually agreeable point at or beyond the property line. So ito yung structure na ginagamit sa electric power transmission na kahit along large distances pa yan ay kaya makapag-transfer ng electrical energy. And si overhead service is nagko-consist lang ng one or more conductors. So next is the service entrance switch. So the purpose of the electric service switch is to disconnect all the electric service in the building except emergency equipment. So sabi dito, yung purpose lang ng service entrance switch natin is dinidisconnect nito lahat ng mga electric service sa mga buildings. Pero except sa mga emergency equipment na necessary talagang magamit. Next is electric metering. Metering must be provided at either the utility or the facility voltage and at either the service point or inside the building, which must be accessible to the utility meter reader. So sa electric metering naman, ito yung devices na ginagamit upang ma-measure or masukat yung mga electricity na nako-consume natin sa pang-araw-araw. So yun yung ibig sabihin ng electric metering.
Main distribution panel. The main and distribution panels connect to the electric power feed to the house and divide the electrical current into circuits. So, a distribution panel is found in just about any home. To put it simply, distribution panel is where the main source of electricity is controlled. Panel and cabinet mounting. Panel boards are classified as flush type or surface type. Flush-type panel boards are those that have the trim and doors practically flush with the finished surface of the wall. So, the difference between surface and flush-mounted panel. A flush-mounted panel goes in the wall. A surface-mounted panel goes on the wall. The difference is in the cover. Usually, surface covers are the same size as the outside dimension of the panel itself. A flush cover is larger to cover up the edge of both the panel and the wall material. Panel boards. A panel board serves basically the same function as a switchboard, except on a smaller scale. That is, it accepts relatively large block of power and distributes in smaller blocks. So, a panel board is a component of an electrical distribution system which divides an electrical power feed into branch circuits while providing a protective circuit breaker or fuse or each circuit for each circuit. In a common enclosure, a panel board serves to protect branch circuits from overloads and short circuits. So, ang panel board are frequently divided into two categories. First, lighting and appliance branch circuit panel boards. Second, power panel boards, also called distribution panel boards. There are four different types of electrical panels: the main breaker panel, fuse box, main lug panels, and sub-panels. The main breaker panel is the mother of all the panels in your house. It regulates the circuit breakers and the electricity consumption within the home. Fuse boxes are made up of small fuses which are designed to prevent overloading within your circuits. The main lug panels are comprised of line wires that run into lugs, eliminating the need for the main breaker. Sub-panels are electrical panels that get their energy from the main panels through a particular circuit. They allow you to control the electrical consumption of members of your household. Guided example of simplified load computation. Given a small family dwelling, type of service 115 voltage over 200 voltage, single phase, 3 wire, 60 Hz. The loads are as follows: 12 lighting loads which are divided into 8 inside the house and 4 outside the house. 12 6 duplex or 12 per outlet. Convenience outlets for small appliances. So for circuit 1, lightning load inside the house, 8 lightning outside at 100 watts. So electric power sub 1 is equals to 8 lightning outlets times 100 watts per 1 outlet is equals to 800 watts. So next is electric current is equals to P sub 1 over 230 voltage. So equals siya sa 3.48 amperes. So for 3.48 amperes, use A15A ang positive wire, 14 AWG or 2 mm squared TW, and a 15A circuit breaker. So ano ba yung AWG? So yung AWG is American Wire Gauge, is the standard way to denote wire size in North America. In AWG, ito yung habang lumalaki yung number ng size, lumiliit naman yung wire diameter and thickness. So yung TW naman, ito yung thermoplastic, high heat, and water resistant. So sila ay klase ng wire. So for 14 AWG wire, use a 1/2 inch or 13 mm conduit. So for circuit 2, lightning loads outside the house, 4 lightning outlets at 100 watts. So electric power sub 2 is equals to 4 lightning outlets times 100 watts over 1 outlet is equals to 400 watts. So next is electric current sub 2 is equals to P sub 2 over 230 voltage is equals to 1.74 amperes. So for 1.74 amperes, use a 15A ang positive wire, 14 AWG or 2 mm squared TW, and a 15A circuit breaker. So for 14 AWG wire, use a 1/2 inch or 13 mm conduit. So for circuit 3, convenience outlet, 12 outlets at 180 watts. So electric power sub 3 is equals to 12 convenience outlets times 180 watts per 1 outlet is equals to 2160 watts. Next is electric current sub 3 is equals to P sub 3 all over 230 voltage. So So, equal siya sa 9.39 amperes. So, for 9.39 amperes, use a 20A ang positive wire, 12 AWG. So, ito yung sinasabi ko kanina na habang lumiliit yung number ng size niya, lumalaki yung diameter naman ng diameter at thickness ng wire. Diba? Or 3.5 mm squared TW. And a 20A circuit breaker. For 12 AWG wire, use a 1/2 inch or 13 mm conduit. So, for electric current total is equals to I sub 1 plus I sub 2 plus I sub 3. So, equal siya sa 14.61 amperes. Para naman sa electric power total, equal siya sa P sub 1 plus P sub 2 plus P sub 3. So, equal siya sa 3,360 watts. So, para ma-check natin kung tama yung ginawa, kung tama yung nakuha natin sa I total. So, I total is equals to P total over 230 voltage. So, 3,360 watts over 230 voltage is equals to 14.61 amperes. So, tama lang. Applying an 80% demand factor according to the code. So, I ref is equals to I total times 0.8 is equals to 14.61 amperes times 0.8 is equals to 11.69 amperes. So, for feeder to branch circuits, use a 20A ang positive wire, 12 AWG or 3.5 mm squared TW, and at least a 20A circuit breaker. For service to main breaker, use an 8 AWG, the minimum service entrance size wire. So, yung 8 AWG na to, mas mataba, mas malaki na yung thickness niya.